Systematic HVACR Troubleshooting.
Hi, I'm Alan Pratt. Troubleshooting is based on the natural human desire to discover why things happen. Little children grow up full of questions, like, why doesn't the moon fall down? Or, Daddy, why are peas green? And each answer you come up with leads to another question. Well, that same human curiosity is what drives the process of troubleshooting. As an HVAC technician, you aren't satisfied to know that a condenser is iced up. You ask why. That's because the problem you see is often just a symptom of an underlying problem, one you don't see. So, when you're on a service call, you're doing exactly what detectives or doctors do. Whether you call it diagnosing or troubleshooting, you're still analyzing symptoms to discover the root cause of a problem. The purpose of this program is to urge you to consider the way you troubleshoot HVAC problems and to look for how you might make improvements in 3 areas: your HVAC knowledge, your troubleshooting skills, and your customer service skills. Let's start by taking a look at the kind of HVAC knowledge you need before you can even begin to troubleshoot.
Here we've got a low temperature, low pressure vapor or liquid entering into the evaporator. It's moving through the evaporator.
To start with, you need to understand the fundamentals of HVAC systems, including the theoretical aspects of refrigeration, such as the refrigeration cycle,
We're using a transformer to step down
electricity and electrical circuitry,
so that when we get the wire,
and the operation of electromechanical devices such as motors and compressors.
this looks like it.
In addition to general knowledge, you have to know the specific systems, equipment, and components you're working on. You'll need to understand how the controls are designed to operate and in what sequence they are electrically activated. A thorough understanding of the basic test equipment used in your work is essential as well. In addition, you need to understand the latest EPA regulations for the use and handling of refrigerants. It's not only for your own safety and the protection of the environment, it's the law.
That's a lot to know. You might be working on equipment that's brand new, 20 years old, or equipment that you've never seen before. So to stay on top of things in this profession, you have to be a lifelong learner.
The skill of troubleshooting is a process of elimination that can be broken into 7 steps. First, verify the complaint. Then, gather information about the problem. Perform a visual inspection to look for obvious problems. If the problem isn't obvious, isolate the root cause of the problem by performing tests. Once you have isolated the problem, correct it by repairing, replacing, cleaning, or adjusting any malfunctioning components. Then, test the system to make sure it's operating properly. And finally, wrap up the service call. Now let's look at the steps one at a time.
You don't have any heat in the building?
Well, just in the classroom area particularly. The rest of the building is fine.
Verifying the complaint means making sure you know what the customer's complaint is.
So it's just a classroom that has the problem.
Right. There's some warm air coming in.
When I turn the fan to the on position, it works. But then when I turned it to the auto position and turned the thermostat to cool, then it wouldn't work.
Make sure the unit is doing what the customer says it is doing. You should be able to recreate the conditions described by the customer. Be wary of customers who try to do your diagnosis for you. Make sure they describe symptoms instead of telling you how to correct the problem. If you have to, probe a little.
So what seems to be your problem?
Well, we have no cold air coming from our registers.
Okay, did you happen to check the circuit breaker?
No, I figured it wasn't that.
What makes you think that?
Because the blower in the basement was working and the unit outside was working as well.
The condensing unit?
Yes, that's it.
Okay, why don't I take a look at the system?
Taking the time to verify the complaint can even reveal that the problem could have been solved by the customer.
I don't think so.
You didn't change the setting at all?
Nope.
Okay. Do you happen to know where your old thermostat is?
It's in the trash.
Do you think you could find it?
No, they came and picked it up this morning.
It's not that people are dumb, it's just that they may be upset or jump to conclusions and forget to check the obvious. That's where a good dispatcher comes in.
Service, Jared speaking.
Yes, I'm having a problem with my
Ideally,
furnace.
the dispatcher
Okay,
will
can I have your
verify
address?
the complaint by asking questions and having the customer perform simple system checks before you ever show
Would you be
up.
able to do me a favor and check your thermostat to tell me if it's in the auto position?
Okay.
Not only can this save the customer the cost of an unnecessary service call, it builds a lot of goodwill.
Okay, can you put it in the on position and check if there's air coming out of the vents?
Okay, so what's the problem, Jay? Fan runs in the on position but not auto.
The dispatcher should be able to provide you with information when you receive the call. For example, the correct name, address, and phone number of the customer, a description of the complaint,
Gas?
the make, model, and type of
They have a flame.
HVAC equipment, and
Okay,
whether
check
the
that
problem
also.
is an emergency.
All right, I should be there in about 15 minutes if you want to let them know. Thanks, Jay. Bye.
How old is the unit?
About 8 years old, but we just moved it here about 2 weeks ago.
What you don't
Does it give
learn
you
from the
problems
dispatcher,
before you
you'll
move it?
need to find out from the
No.
customer.
Worked just fine.
For example, ask when the customer first noticed the problem. How was the unit working prior to the problem? What events may have led up to the problem?
The people that moved it, did they drop it or bang it?
Well, I'll tell you the truth. A buddy of mine and I were trying to move it, and it was really heavy. We did drop it one time, but I think it was okay.
The service history for the unit you're servicing is another important source of information.
Looks like back in '96 we replaced the blower motor.
This may be available at your
All right,
home
thanks.
office,
Bye.
or the customer may have kept old invoices. Look for patterns or recurring problems. You should also keep up with the latest technical bulletins and warranty information for equipment you service. The dispatcher should have this type of information in the office.
It's easy to see how important the dispatcher can be in the beginning of the troubleshooting process. But when it comes to step 3, visual inspection, you're on your own. You've got to be there. This step should really be called sensory inspection because you use 4 of your 5 senses: your eyes, ears, nose, and sense of touch. The only sense you definitely do not want to use is taste.
The visual inspection is a preliminary check of the system, both with the power on and off. The purpose is to look for obvious symptoms of the problem, such as a dirty filter, a filter that is missing altogether, a fan that doesn't operate or has damaged or missing blades, a belt that is broken, worn, or loose, broken or loose wires, dirty or corroded coils or fins, damaged piping, blocked supply or return ducts, or overheated or burnt wires and electrical connectors. With the system on, look for other symptoms, such as correct fan rotation. Listen for any abnormal sounds, such as hissing, which could indicate a leak in the sealed system, or squeaking, which could indicate a worn bearing. Check for abnormal odors, such as mildew, mold, burnt insulation or rubber, or leaking refrigerant. Carefully feel for the temperature of lines and components by patting. Temperatures can be hot enough to cause serious burns.
In the real world, verifying the complaint, gathering information, and visual inspection overlap, and the order that you do them in will vary depending upon the situation. The important thing to remember is to check the simple things first before you get out your tools and start taking things apart.
If the root cause of the problem is obvious, you can go right on to step 5 and correct the problem. But if the problem is not obvious, you'll need to dig deeper and perform whatever component or circuit tests are necessary to isolate the problem. Isolating the problem is a logical, step-by-step process of elimination using test equipment. It starts with knowledge of the specific equipment or component being tested. Different makes and models of HVAC equipment operate on the same basic principles and have the same types of systems. So, even if you're dealing with a make and model of equipment you've never seen before, the schematic plus your general knowledge of HVAC systems will often be enough to help you solve a problem. If additional information about the equipment is needed, you should consult the manufacturer's service manual or troubleshooting charts for additional help. Ideally, the dispatcher will have a library of this information which you can access electronically or by phone.
Okay, what's the model number on that?
An experienced dispatcher can also be an important source of technical support. When you discover something that isn't working properly, you need to ask why. If a part is defective or needs maintenance, you've found at least one cause of the problem. You will go on to replace, clean, or adjust it. But a good part can perform badly if it's not getting the right input voltage. In this case, keep working your way backwards until you get to the source or root cause of the problem.
You know you're at the end of the troubleshooting trail when you find the malfunctioning part or circuit or condition that caused all the symptoms. That's the root cause. And when you find it, you can then move on to step 5.
Mrs. Jones, I had the opportunity to check your unit outside, and it does need to be cleaned.
Before performing repairs or replacing a part, explain your diagnosis to the customer, including an estimate of what costs are involved. Make sure you get permission from the customer before beginning any repair or replacement.
Once a repair is finished and the system is up and running, and you're tired and it's the end of the day, it's tempting to just pack up and go home. But just because the unit is up and running doesn't mean that it's up and running correctly. Watch.
I promised my son that I would make his softball game, and my last call of the day was at a commercial establishment. We had a contract with them. I got there. It was a rooftop unit. They didn't have any air conditioning in their kitchen area. Went to the roof, shut the disconnect off. I could hear the condenser was running. I thought the unit was working, but when I pulled the panel off and turned the disconnect back on, I realized that the blower motor wasn't operating. In fact, I could smell it was hot. I felt it. I touched it. It was hot. Took a reading on the windings. Found out that the windings were open. Thought this thing needs a new motor. Went down, got a motor, put one in, flipped the disconnect back on, left for the day, and I'm on my way home. And I'm headed to my son's softball game. And dispatcher radioed me to tell me that the system wasn't working. Still wasn't working. So I go back, and sure enough, I never checked to see if the blower actually came on. I heard the condenser unit running, and I assumed that it was. I didn't go inside at all. And here this motor had overheated too. I didn't take the time to try to determine what had caused the original motor to overheat. So through my diagnosis, I found out that really the problem was this was a 3-phase system. One of the fuses blew on one of the legs, and the motor was single phasing, and that's what caused the original motor to overheat.
So it's important to test the system after the repair to make sure the problem is solved. It's the best way to keep your customers happy and to avoid expensive and unnecessary callbacks.
Testing a repair often means you'll need to wait a short time on site to make sure that correct temperature ranges are achieved. For example, testing the temperature rise of a furnace or the temperature drop across an evaporator coil. In some cases, you may even need to leave and return later after several hours to check on a system.
If tests show that the problem hasn't been solved or another problem appears, you'll need to go back to step 5 and perform additional tests to isolate the problem.
If the problem has been resolved, you can move to the final phase of the troubleshooting process. To complete the service call, explain the charges on the service invoice with the customer and make sure all paperwork is complete. If appropriate, teach the customer how to better care for or operate the system in order to avoid a repeat of the same problem. And make sure you have answered any questions the customer may have before you leave.
You may have noticed that the troubleshooting process begins and ends by dealing with the customer. This underscores the fact that without customers, you wouldn't have a job. So developing good customer service skills is absolutely critical to your success as an HVAC technician. Here are some tips to keep in mind.
Hi, I'm Randy from ProTech.
Hi, glad you can make it.
So I understand you don't have any heat in the building?
Well, just the classrooms we're particularly having problems with. The rest of the building is fine.
Okay,
Remember to show respect to your customers.
There are 4 heating
When you
systems
arrive at the
units
job
on
site,
top of
introduce yourself and your
Just the
company.
classroom that has the problem.
Be friendly
Right.
but
There is
formal.
some lukewarm air
Never
that's
address the
blowing out,
customer using the
it's
first
definitely
name.
not as warm as it used to be.
Pay attention to your
when did you first
appearance.
notice this?
Clean
First
clothes,
notice it,
clean
this
shaven,
Sunday morning
and
when
well
we
groomed.
tend to wear jackets to Sunday school
I guess I should tell you I installed a new thermostat yesterday.
You installed the thermostat?
Yeah, the fan switch was shutting off, so I put a new one in. Do you think I screwed up?
I'm not sure. Let me take a look at it for you.
Never criticize the customer for mistakes they may have made which contributed to the problem.
I don't know, I just shut the whole thing off. I used to have a window conditioner and I never had any trouble with that.
When did you first notice it wasn't cooling for you?
If the customer
right
is
after
upset
lunch,
about
that's
a
when I
problem
called you.
or the cost of
I already
correcting it,
checked it.
don't take it personally.
I turned the fan
Listen
to the
without
on position
interrupting
and it worked.
and show sympathy.
And then
When
I
they
turned
have
it to the
calmed
on
down, you
position
can get back to the
and
problem at
turned
hand.
the thermostat to cool.
I hope this program has helped you reflect on how you troubleshoot and what changes you might make to improve your effectiveness on the job. Planning to upgrade your skills and knowledge on a regular basis is the best way to make sure that you're ready for any troubleshooting situation that you may encounter in the complex field of heating, ventilation, air conditioning, and refrigeration.